Hey guys, this is Mr. Sal. This is a lesson where we look at equations involving radicals. So thanks for watching. Don't forget to comment in the section below and like and subscribe. This power rule stuff, I don't know. Seems like we've heard that name before, but it's a little bit different now. With equations, it's just like any other equations. If you do something to one side, you got to do it to both sides. So if I had x equals the square root of 17, then I would square both sides to get x squared equals 17. I know that's kind of weird maybe right there, but it was easy for me to show that. Just if you do it to one side, you got to do it to the other side, but then you got to check to make sure that whatever answer you get is actually a solution. Because the key word here is among the solutions. And so if you have multiple solutions, not all of them may be possible, right? Just like we've seen, x minus square root of x minus 5 equals 0. The domain indicates that x has to be greater than or equal to 5. It's the same idea with that, okay? So if a equals b, then a to the power of n equals b to the power of n. Again, if you raise it to one power, one side of the equation, you got to do it to the other side. Just remember, again, it's not guaranteed that whatever solutions you find are actual solutions. I mean, you did all that work, just check. Now, in the past, we haven't forced you guys to check. We're still not going to. But since this is kind of part of the whole spiel on principle of powers, power rule, radical equations, whatever you want to call it, we kind of expect to see you guys do it. Alright, so this one's kind of like that example I showed, but it's now the square root of x instead of the square root of the number. So we're going to take both sides and we're going to square it to get rid of that square root, okay? Because if I do it to one side, then I should do it to the other side. And in this case, I'm kind of manipulating it just to get rid of that square root. So, square root of x squared is just x. And that would equal 4 squared, which is 16. But once again, we should check, though, right? So I'm going to check that square root of, now it's 16. Does it equal 4? Sure does. 4 equals 4. Checked. The index will indicate what power you need on both sides to get rid of that radical. Square root of x plus 4 equals 9. So still looking at a square root. So I'm going to do the same thing I did on that last one, just square both sides. So now I've got x plus 4 equals 81. And some of you guys may feel a little weird about that because we just squared a binomial, but it was the square root of that binomial, okay? In other words, what I could have done is written that as x plus 4 to the power of 1/2, and then I took it to the power of 2, right? Which would have given us x plus 4 to the power of 2 over 2, which is just x plus 4. Well, to solve this is, I mean, if we had started with this equation, we would have felt great about it. And now that we have it, we can still feel great. Just subtract 4 from both sides. X equals 77. But again, we should check that, right? So I got the square root. Now it's 77. And if I add 4 to that, the square root, then I should get 9. It's a question mark for now. That's a square root of 81. Does it equal 9? Yes, it does. So there we go. It's good. Well, we get so used to just squaring everything that on this one, we just want to square that, and then we want to square the -1 as well, but don't, okay? Because, I mean, you know, even if you thought that was the difference of squared and squared that 7m minus 7, you'd have to square the 8 as well, which is going to make things really, really bad, okay? So don't do it, right? What I mean by that is you'd have square root of, I didn't make that big enough. Square root of 7m minus 7 minus 8 times the square root of 7m minus 7 minus 8. I don't want to multiply those two, and I hope you don't either. because that would be extremely painful. Okay, so we're not going to, and there is a way to avoid all of that. Yeah, so I guess that's another thing, right? Maybe you just square there, and then you square this one as well. Well, we can't do that because you need to include the -8 in the squaring. So the objective then, if you see something like this, kind of like with the absolute values, which were a long time ago and no one remembers anymore, but we're going to manipulate this equation for the square root. So I just want, in the end, the square root of something to equal something else. Because then when I square both sides, then it does get rid of the square root, just like it did on that last example, right? That's very good. Add 8 to both sides. Well, now you did exactly what we wanted to do, and that's to get the square root of 7m minus 7 on its own side of the equal sign. So -1 plus 8 is 7. And now when I square both of these, then I get 7m minus 7 equals, now that's 49. Then I'll add 7 to both sides. And we've seen a lot of that today. Divide both sides by 7. M equals 8. Well, that was so different and so new, and we feel so good about it that we want to quit right there. But don't, because we've got to plug it in now, right, to make sure that it is an actual solution. Yeah, we're looking at this with a question mark now. So I've got the square root of 56 minus 7 minus 8. Does that equal -1? So that's the square root of 49 minus 8. Does that equal -1? Well, you'd get 7 minus 8, which does equal -1, and we're good. I don't know. This one's not really very different, but what the heck? Let's do it. Again, I'm just manipulating this equation for that square root, so I got to get rid of that +2 first by subtracting 2 on both sides. I don't want that 7 multiplied by it either. Although I could multiply or square both sides now, but I don't know. Doing it's going to give us a fraction as well, which makes it uglier. What the heck? Alright, so I got rid of that, and I've got the square root of x plus 10, and this equals 6/7. Now again, you could have squared both sides at that point because it's just multiplication, but I'm going to square it right now. So I'm going to square the fraction and the square root. So now I've got x plus 10 equals, that'd be 6 squared, which is 36, divided by 7 squared, which is 49. So this just shows that it doesn't matter when you squared. You should have ended up with the same fraction right there. And now to solve this, we'll subtract 10 from both sides. Oh, not 10 over 10, but minus 10. Alright, I've got 36/49 minus 10, but that's no good because I do need common denominators. And in this case, I'm going to use 490. So I'm going to multiply this one by 10 over 10. And that's really 10 over 1, which I'm now multiplying by 49. Oh, space there. Yeah, common denominators are 49. What the heck? So this gives us the new fraction. I'll still write it in there. Well, subtracting those, I would get negative 454 over 49. All right. And most of you guys want to box in the answer, but I definitely wouldn't, because that's kind of a freaky number, right? So I would check. Just plug that into the radical multiplied by 7 and add 2, right? All right, we'll just evaluate this because I ran out of space right there. Should equal 8, right? Question mark. And we'll just plug it into the calculator as we have it. All right, this is a good one. We like this one because it's very different. We already got the square root on one side all by itself, so I'm going to square both sides on this. We just have to be careful with this one because now when I square the right side of this equal sign, it's a binomial. So it's really x plus 9 squared, which also turns out to be x plus 9 times x plus 9. right? So that ends up being x times x plus 9, plus 9 times x plus 9, right, with distribution on those. And I get x squared plus 9x plus 9x plus 81, which, whoa, whatever, would give us x squared plus 18x plus 81. Now, don't worry, I haven't forgotten about the left side of that. I squared that x square root of x plus 51, which gives me x plus 51. And now that's on the left side of that equal sign. Well, this takes us way back into Module 5, which is when we love things. So I wanna make this, yeah, you can call it a quadratic, this polynomial equal to 0, so that I can factor it and find out what values of x would make it 0. So I'm going to subtract x from both sides, looking at common terms, or like terms, and then I'm going to subtract 51 from both sides as well. Fortunately for us, though, the coefficient of x squared is a 1, so we're going to use the rule, just split it up, not have to worry about factoring by grouping. So I need two factors of 30 that add up to 17. How about 15 and 2, right? So now I can split this up into two binomials, x plus 15 and also x plus 2. Now, of course, this equals 0. So I need that x plus 15. If that was 0, then it would give us a true statement, which would give us x is negative 15. But also, if I can get x plus 2 to equal 0, that would give me a true statement as well. And that, in that case, x is negative 2. But remember, especially when we're looking at multiple answers like this, we just need to make sure that both of them would give us a true statement in the original expression. So we'll start with x is negative 15. Alright, so x is negative 15 and negative 15. So that's the square root of negative 15 plus 51 is 36. Should equal negative 15 plus 9, negative 6. Now some of you guys don't need to continue because you can't get the square root of something to be a negative. However, the square root of 36 is 6, and 6 does not equal negative 6. So 15, as it turns out, not an answer. Well, let's try negative 2 then. So we'll plug negative 2 in there for x and evaluate. Again, that's a question mark. Should have been there as well. Negative 2 plus 9 is 7. And that's the square root of 49. That feels good. Square root of 49 is 7. 7 does equal 7. And x is negative 2 is our only answer for this problem. Here we got 5 times the square root of m equals the square root of 5m plus 3. And just to acknowledge that exponent of 5 is 1. We're going to need that when we square both sides, which is what I'm going to do now. So I'm going to square that. And also this 5m plus 3. Alright, so we needed that because it's not 5 to the power of 1 now, it's 5 to the power of 2, right? I'm distributing that 2 into the parentheses for the exponents. So I've got 5 squared, which is 25, and the square root of m squared, which is just m. This should equal, now, the square root of 5m plus 3 squared is 5m plus 3. Hey, that's not too bad. We can solve that one. Subtract 5m from both sides. And then we'll divide both sides by 20. Get m equals 20/3.
Well, where did the...
Yeah, 3 over 20 is better, by the way. So, there we go. Oh yeah, we should check though, right? If you plug this in, you'll get a decimal value, right? Well, if you weren't going to plug this into the calculator, I would kind of be looking at the square roots right there. So, let's say we didn't know, or we didn't have a calculator with us on the exam, which would be kind of ludicrous, right? But we need to combine these, so 5 times 3 is 15/20. I'm going to kind of breeze through this. So that's really 15/20 plus 60/20. which is the same as the square root of 75/20ths. I'm not going to simplify that because we need the 75, okay? What I'm going to do, instead of having the 5 right there, I'm going to make it the square root of 25 times the square root of 3/20, so that I can combine the square roots. And then I've got the square root of 25 times 3/20, which is the square root of 75/20. And so we got the same square root fractions for both. And now we can circle with hopefully a lot more confidence, m equals 3/20. Now, does the decimal work? Yes. It is irrational though, so we have to be at least slightly careful to, I don't know, maybe the millionths. All right, this one I think maybe looks a little bit more complicated than it actually is, because we got the square roots on both sides. It's not adding or subtracting anything, which is good, because that would make it really bad. I'm just going to square both. So I got 5m plus 7 equals 9m plus 2. And this is just a regular equation that we're solving now. I'm going to put my m's on the right and my numbers on the left. So I'll start by subtracting 5m from both sides. And also 2 from both sides. And I got 5 equals 4m. We'll just divide both sides by 4. So m now equals 5/4, which we should check, right? So I got the square root of 5 times 5/4 plus 7, and this should equal, question mark, square root of 9 times 5/4 plus 2. And we'll just evaluate this. There we go. We got that. So we know now that the answer is m equals 5/4. Okay, there's our first cube root that we've seen today. And we'll need to cube then both sides. And 1 cube is a pretty easy number to cube. So I end up with 1t is just t. T minus 1 equals 1. So I'm going to add 1 to both sides. And I got t is 2. So just to check, right? Cube root of 1 times t. And we're saying t is 2. Cube root of 2 minus 1, does that equal 1? So that'd be the cube root of 1 equals 1. Cube root of 1 is 1, so that checks off. This one's almost exactly the same as the last one. It's just now it's got that minus 2, right? But we don't want it there. So we're going to add 2 to both sides. Right? I mean, this was the same process when we had the square roots. It's going to work the same way with the cube roots. So now I got 3 equals the cube root of x plus 3. And now I'll cube both sides. And I got x plus 3 now equals 27. Minus 3 from both sides. And x is 24. So we just want to check though. So I got the cube root of 24 plus 3. And we're just going to check to make sure that's true. 24 plus 3 is 27. Cube root of 27 minus 2 should equal 1. That's 3 minus 2 equals 1. Yep, that's true. So we know it's x is 24. All right, just please don't quit on this one because there's lots of words. All right, it's really not nearly as bad as it looks. We'll read it anyways. Please use this formula to estimate the speed of a car, v, so v is the speed of the car, right, in miles per hour, based on the length, L, in feet of its skid marks when suddenly braking on a dry asphalt road. At the scene of an accident, a police officer measures the car's skid marks to be 219 feet long. Approximately how fast was the car traveling? And we'll round our answer to the nearest tenth because, like we've seen, square roots generally produce irrational values when we take the square root of a non-perfect square. Not that anyone cares. But the formula, the velocity is the square root of 20 times the length of the skid. And, well, we see that the length of the skid on this one is 219 feet. So I'm just going to replace the length with 219. So I would multiply those. Yeah, so the velocity is the square root of that stuff right there. And what we actually do want is the velocity, which is the speed right there. So I'm just going to plug that into my calculator, and it should give me some 66.2. But don't forget to label that, right? Miles per hour. Bam. So the speed of a car that was braking on a dry asphalt road that produced a skid mark of 219 feet. It was going 66.2 miles per hour. I have no idea how legitimate this is, but it sounds cool.